Hello everyone, you are learning physics from Uncle Irodov, and in this module we will be solving Irodov's 1.3. This problem is about a car that starts from rest, then it accelerates, travels with a constant velocity and then finally decelerates to again stop. They have provided us with some values. They have given us the values of acceleration and of course then the deceleration, the total amount of time for which the car travels and its average velocity during that entire motion. And they're asking us to find out for how long does the car move uniformly. So the first things that we do is, of course, change the average speed that they have given to SI units, that is here, and using the total amount of time for which the car travels, find out the distance that the car travels, that is equal to 500 meters. Now usually such problems become easier to solve if instead of using equations we use a VT graph. So let us try to draw a VT graph of this situation and see how does it look like. This car starts from a certain point O, it accelerates, acceleration is shown using the sloping line here, accelerates up to A, then moves with a constant velocity up to B, and then decelerates to stop at this point C. This is the accelerating part OA, this is the decelerating part BC. The time t1 for which it accelerates is equal to the time t1 for which it decelerates, and it spends a certain amount of time t2 in between traveling at a constant velocity. The maximum speed that it attains is omega t1. That can be obtained using v is equal to u plus at. Now, two equations can be framed using this motion. One is 2t1 plus t2 is equal to the total amount of time for which the car travels. So that is known, that is one equation. Second, the area under the graph is the total amount of distance traveled. The area under the graph is area of these two triangles. So we have 2 times half into base into height plus the area of this rectangular shaded region. So that is t2 into omega t1, all that should be equal to 500. We would like to express this 500 in terms of V average into tau. So 1 and 3 are a set of two equations in two variables t1 and t2. We can eliminate t2 from here to have an equation only in terms of t1, that is here, and then we can solve it using the quadratic formula to find out two values of t1, and these two values of t1 here, which are shown in equation number 5, will help us to find out the values of t2. Now of course, because t2 cannot be negative, we will have only one final value of t2, in which after inserting the values that he has provided, we will get the answer as 15 seconds. So this was a pretty simple problem if you think of solving it using VT graphs. I'm hoping that you have learned something from this video, and I'm also hoping that I will see you in my later modules as well.